Hey class, welcome back to week 4 of remote learning. I just want to say you guys have been doing an awesome job for the first 3 weeks. And as you guys probably heard from the governor, right, this is how the rest of the year is going to be all remote learning like this, all right? Which is pretty unfortunate and sad that I'm not going to be able to see your faces physically. But again, I hope that we can have another Google Hangouts meet probably in the future, probably not this week, but next week, just to kind of say hi again. All right. So we are going to start a new chapter, chapter 8 here. However, everything we learned in chapter 7, we're going to need to apply here on chapter 8, right? In algebra, a lot of the skills and stuff that we learn in the past kind of just build up on itself. All right. So here are the notes for today, right? Again, print out these notes if you can. Otherwise, take notes kind of where I tell you to write things down, okay? So here we go. This is 8.1, solving polynomial equations in factored form. All right, so first we're going to start off with a little warm-up, right? We're going to solve these linear equations, right? So why don't you guys pause the video, all right, and write down your answers for 1, 2, and 3, all right? Or write these down on a separate sheet of paper and kind of quickly solve these 3 linear equations. All right, how'd you do? All right, so number 1, right, first we have to add 2 to both sides, right? That's how we solve these linear equations, right? Inverse operations, so we get x is equal to 2. All right, for number 2 here, it's 3x minus 12 equals 0. Well, to solve this, right, first we have to add 12 to both sides. Add 12 to both sides, and then we get 3x is equal to 12, right? And then we divide by 3 to both sides, and we get x is equal to 4. All right, and then the last warm-up problem number 3 here is negative 2x plus 6 equals 0, right? Again, first we got to subtract this 6 over, right? This whole idea of inverse operations to isolate the variable, right? A goal for solving is to get that x all by itself. All right, and when we do, we kind of undo everything to get that x by itself, right? So here we have negative 2x is equal to negative 6, right? We divide by a negative 2, right? And then a negative 6 divided by a negative 2 is a positive 4. Oops, sorry, positive 4. Nope, it is a positive 3. Look at that, it's too early for some math, just joking. All right, x is equal to positive 3. All right, so again, hopefully that's just a quick little review warm-up, all right? So the next question here says, how many answers or solutions did we get for each of these problems, right? Well, it looks like each one of these problems only had one solution. All right, these solutions can also be called your roots or zeros of polynomial equations, all right? Remember, polynomial it's a number, it's a letter, it's a combination of numbers and letters, right? So solutions are also called these roots or these zeros, all right? We're talking about polynomial equations, all right? So now we're going to talk about some special properties of that number 0, right? The number 0 has some special properties. They're going to come into play in these notes here today, all right? So here we go. We're going to complete these equations, right? Number 4 says 5 times 0. Well, that gives us 0, right? Anything times 0 is 0, right? Number 5 says 10 times 0 is, 0, right? And number 6, 9,437 times 0, guess what, is also 0, right? So that's one special property of 0, right? Anything times 0 will always result in 0 for the solution. All right, so now we're going to apply this special properties of 0 into a new property called the zero product property. All right, the zero product property, right? 0, 0, product, right, means multiplying something, and the property, right, that's just what we're going to call this, in the zero product property. All right, so defined, right, the zero product property says if two numbers or expressions are multiplied together and equal to 0, then either one or the other number or expression equals 0. Okay. So here you go. This is another way we can look at it, right? It states that if some number A times some other number B is equal to 0, then that means either A is equal to 0 or B is equal to 0. Okay, so now let's see how this property is explained using some fruit. All right, so if an apple times an orange is equal to 0, then either that apple or that orange is equal to 0. All right, hopefully that kind of makes a little sense here, right? Kind of explaining it different ways here. And here's a special note here at the bottom, right? This property can be used to solve any polynomial equation when one side of the equation equals 0 and the other side is a product of polynomial factors, right? We've been dealing with a lot of polynomial factors, right? And product, right? That's just the word for multiplying, right? So when some polynomial factors are being multiplied and is equal to 0, then we can apply the zero product property. All right, so let's do some examples. All right, so now when I do these examples is if you did not print out these notes, right, this is the time that you want to get out that sheet of paper and kind of write these examples as long as I'm doing them. All right, so example 7 here, right, we're going to use the zero product property to solve these factored polynomial equations. All right, number 7 is x plus 1 times x minus 2 is equal to 0. All right, so we're going to apply this zero product property. That means either this polynomial expression or this polynomial expression is equal to 0. So we are going to write two separate equations and solve for 0. All right, so that means that either this x plus 1 is equal to 0, right? That's kind of like my apple. Or this x minus 2 is equal to 0, and that's kind of like my orange here. Right, and just like in our warm-up, right, we know how to solve one-step equations here, right? So we're going to subtract 1. So x is equal to -1 is one of my possible solutions. All right, and then add 2, x is equal to 2 is my other solution, all right? So here I have two solutions for these types of problems, right? Where the warm-up, I just had one. All right. And we'll talk about that here in a couple minutes as we do a couple more of these problems together. All right. Example 8, we have x plus 3 times x minus 4 is equal to 0, right? So again, I have one polynomial expression here, x plus 3, and I have another polynomial expression here, x minus 4, and it equals 0, and I'm multiplying, right? So then I can use this zero product property to solve now. All right, so x plus 3 is equal to 0. Means I'm going to subtract 3 from both sides. You get x is equal to -3. Or you have x minus 4 is equal to 0. And this time I'm going to add 4 to both sides to solve. And you get x is equal to +4. All right, so I have two different solutions here. All right, let's look at number 9. Uh-oh, I don't see that multiplication dot in between these two polynomials, right? But that's okay, right? That is implied, right? When things are being multiplied, right? They're just kind of next to each other in parentheses, right? I don't always have to have that little dot here in the middle, right? I did it for the first two examples just to kind of show you, right? But really in algebra, we don't need that little dot there, right? Because things are next to each other in parentheses. That means they're being multiplied. All right, in this case, we have 3x minus 4 times x plus 6 is equal to 0. All right, so same thing, right? We're going to set each one of these polynomial expressions equal to 0 and solve. Right, that means 3x minus 4 is equal to 0, or x plus 6 is equal to 0. Right, each one of those polynomial expressions you're going to set equal to 0 and then solve. All right, so for the blue one here, right, we're going to add 4 first. All right, so this one's going to require 2 steps to solve, right? 3x is equal to 4. And now we are going to divide by 3, right? And here, right, we should be using a calculator, right? Ideally, we would have our TI Inspire in front of us because we don't really want decimals in our answers, okay? We want kind of a reduced fraction, right? And if my fractions can't reduce, like 4/3 does not reduce or simplify, then we just leave it as 4/3, right? Fractions are okay for our answers. All right, and sometimes we're going to get fractions for answers. All right, and then my second solution here, right, minus 6, right, x is equal to -6. So those are my two solutions. All right, so going back to why do I have two solutions? It's because in my problem here, I have two different x's, right? I have an x here, and I have an x there, right? If there are two x's in your problem, then you can get two different solutions, all right? Or two solutions, I should say. Sometimes there might not be different. All right, let's look at example number 10 here. All right, we got a couple more. All right, in example 10, it says 2x times x plus 14 is equal to 0, right? Again, I have two different products that are being multiplied that are both polynomials, right? My first one here is just a monomial, or 2x, right? So I'm going to say that 2x is equal to 0. And my other polynomial expression is this x plus 14. So I'm going to do it in red. X plus 14 is also equal to 0, right? There's that zero product property, right? I have two different polynomial expressions, right, that are being multiplied, right? So this is the product of those two is equal to 0. That means I'm going to write each one of those equal to 0 and then solve. All right, so 2x equals 0. Well, to solve that one, right, we just simply divide by 2. And 0 divided by 2 is just, not 2, it's just 0. Let me clean that up. I don't like the way that looked. So it's just 0. Right? And it's okay to get 0 as a solution. That will happen sometimes, all right? And then my other one here, right, we subtract 14, and we get x is equal to negative 14 is my other solution. All right, again, I have an x, and I have another x, right? So I have two solutions here. All right, let's look at our last two examples here. All right, number 11 says we have 3 times x minus 2 is equal to 0. All right, so again, we have a product here, right? We're multiplying these two terms, all right? So we're going to say that this polynomial expression of 3 is equal to 0. And we're going to say that this polynomial expression of x minus 2 is also equal to 0. All right, so again, we're going to solve for both here, right? Oh, wait a second, 3 equals 0. I can't solve for that. That's not true, right? So there's nothing I can do with that. All right, and then my other equation here to solve is x minus 2 is equal to 0. I can definitely solve that one, right, by adding 2, and you get x is equal to positive 2. All right, so in this problem, I only have one solution. And again, if you notice, I only have one x, right? So I should only get one solution. All right, speaking of x's and solutions, right, look at number 12 here. We get x times 4x minus 1 times 2x plus 5 is equal to 0. So how many solutions do you think we're going to have here for number 12? That's right, you guessed it. We're going to have 3 different solutions here, all right? So we're going to set this first polynomial equal to 0. So x is equal to 0. We're going to set our second polynomial expression equal to 0. 4x minus 1 is equal to 0. And we're going to set our third polynomial expression equal to 0. Right? 2x plus 5 is equal to 0, right? And we're going to solve all 3 of these. Oh, wait, x equals 0. Boom, I'm already done with that one, right? That is a solution, right? X is equal to 0, so that is a solution. All right, and notice how it's different from this one, right? 3 is equal to 0 is not a solution because that is not true. I do not have a variable, right? But if x is equal to 0, I have a solution, and that one solution is 0 here. All right, and then here I can also add 1 to both sides, right? So we get 4x is equal to 1. All right, and then we divide by 4. Again, if this does not divide out evenly, just leave it as a fraction. Okay, so if you don't want decimal answers, just leave your answer as a fraction of 1 over 4. All right, and the last solution here, right, we subtract 5 first. We get 2x is equal to negative 5, right? And now we divide by 2. Again, we don't want decimal answers. We want to leave our answers as reduced fractions, right? So this is just negative 5 over 2 is my last solution here, all right? So I have 3 different solutions because there are 1, 2, 3 different x's in my problem. All right, nice job with the notes. All right, I want you guys to practice some more with doing some IXL. All right, And then we'll be back tomorrow.